Hey engineers, and welcome back to yet another video in the DevSecOps series. And today the topic of discussion is everything you need to know about or worry about when we deal with Kubernetes clusters. So in our today's video, we will be looking at the following topics where first of all we would discuss what are the different 8 pillars of Kubernetes security. Then you know everything you deal with regarding Kate security is not just about tool integration. There are basic things that you need to know about how and what things are involved and how we can secure them. Then we'll see a Kate security model. Then there are different components that need security. So there are about 20 things that we are going to discuss in this section. So it would be a long video. Hopefully and we would try to cover as much as possible in this particular one video. So it would be a community security one shot video for you guys. Then at the end we will be looking at what things we can implement, what type of different controls we need to implement as a part of Kubernetes security maturity model, and then different security tools that will help us achieve in that particular thing. So let's start with the very first stuff where we need to know what things actually are surrounding the Kubernetes cluster. So your application is one thing, again the cluster is one thing, then different components of the clusters are there. Again, if that cluster is being deployed in the cloud environment, so there is a cloud infrastructure that is associated with it. Then comes the authentication and all the other stuff related to AWS services or any cloud services as that requires. So when we kind of look into designing an organizational level Kubernetes security program, we need to keep these things in mind, that there are 8 pillars that we need to secure. So very first is the infrastructure and control plane security. So here what happens, we have uh, the either EKS or any nodes instances, AWS instances that we use for building the cluster. So how do we secure that? That is one stuff. Then there are different security groups along with it. Then there is a network pathway routes that we create. DNS is also part of that. So how do we secure that entire infrastructure that we have built for our cluster to function? Then the most important thing, the control plane, that is having the responsibility of managing the workloads or worker nodes. So that's one pillar. Then we have to look into identity and access security for both the infrastructure, the cloud infrastructure, or the self-hosted infrastructure. We can say as private cloud. Then the access to it, whether you do IAM, whether you do OIDC, you do OpenID, something like that. All this different authorization and authentication methods, mechanism that you know, like SSO, MFA, short or temporary lived access for a couple of hours, then privileged access kind of thing. So these are the different parts of identity and access security that you need to set up for making to make sure that your clusters are secure. And then workload and container security. Most of the Kubernetes applications are containerized, and that's why Kubernetes is built. Kubernetes is for container and orchestration of those containers. So the workload that runs inside the containers and the containers itself. Then comes the network and data security. So access to network is one part, and then access to data is another part. So there are different kind of network attacks that could be possible, and then again, data tampering, data poisoning stuff. If you are using any kind of time, then SQL injection, a lot of different things that are done on data or application layer as such. That's why taking care of these things is also important. Then application and supply chain security. There are a lot of different open source or third party tools we use along these making of CI/CD pipeline, then building that thing, then again deploying that thing, and then making it, monitoring it, kind of stuff. A lot of different tools are involved. So how do you secure the supply chain along this entire pathway? So that is again we need to make sure Then application security itself, that is a simple whole topic in itself, on how we can secure what we need to secure from what different type of threat mechanisms are there. Then there comes policies, posture, and vulnerability management for our entire cluster, and along with it, the components that are there. So you might have heard about Open Policy Agent or Kyverno, something like that. Then you might have also heard about CIS benchmarking, NIST, risk management frameworks, and all these different cybersecurity management frameworks. So all of this uh, could be applicable to your products. And then there comes governance, audit, incident responses, and along with that, runtime detection and observability is one more thing. Deploying an application in clusters is one thing. Then making sure that those deployed applications or workloads or the infrastructure is working smoothly, that is another part. So after all of this, knowing that, oh, now we need to secure these 8 pillars, then what else do we have to do? So it's not just about tool integration as such. Let's see, what do we mean by securing an entire cluster? So we need to know, like, for each of the above mentioned pillars, we need to define controls, how and what things should be implemented to make them secure. Then the technical implementation of those things, yeah, how we are going to implement those things, where they would lie in the entire SDLC. Okay, then who is the owner of these particular controls, who will define the rules, regulations, and who will be in charge of managing that thing. Then what is the evidence, like evidence mechanism that you have for if any kind of vulnerability has been detected, or if any threat is lingering around there and someone tries to attack you, how you manage the alerting of that thing if something goes wrong. That's one stuff. Then how do you create your audit reports for the entire infrastructure along with the applications that are running in? How would you um, kind of show people that whatever you are building is really secure and can hold your data easily, without anyone, without any risk of tampering that data? So those are the few things you need to show in your audit reporting. So that's one. And then once you find out that there is any kind of vulnerability or any attack, then how do you remediate that thing, and what is the SLA, service level agreement, like how fast you can secure your workloads, what are your commitments to that? So these are the few controls or things you need to create, or you need to define, okay, in a particular set pattern. And then, if we talk about a mature Kubernetes security program, what does it include? Okay, it's not just that we install Trivy, Falco, and Kyverno, all of this stuff. Okay, it's not, what we integrated on what point of Kubernetes, so SDLC. It should be able to answer. I mean, the Kubernetes security program should be able to answer, like, what assets do we have right from the beginning? The application, the code, libraries, the infrastructure, the networks we created, the routes, the VPCs, the subnets that are there, then the S3 buckets that we access, then the other SNS or SQS that we use to perform any activity, then whatever in the application, in the infrastructure, in the pipelines, what assets do you have? That is what you need to first of all answer. And you should have a list of this inventory. What assets do you have and what you need to secure? If there is any database, how do you know? Or if you don't know, if you have a database, how are you supposed to secure that thing? So that's why identification of assets is one of the most important thing when we talk about Kubernetes maturity, security programs maturity. Then what are the risks associated with that thing? Okay, what risk right now exist? If let's say my database is not encrypted, if the access is just an admin user and password, and then bunch of other users with their different password, no authentication or authorization policies are set, no role based access is set, everyone is a root user. So you need to determine what risks are there right now with a particular asset that I own under this entire cluster uh, boundaries. Then which controls are enforced to minimize this thing? Let's say if you are using KMS for managing your secrets or kind of access to this particular environments. So that would be one control. Then you may say like there is a vault that we use for authentication purpose, and then retrieving the secrets for people or application workloads to access this database. So are those controls set well? Are they working fine? Is there any problem with them? Do we need to update those controls with something else so that we could add more security, or an additional security component to it? So that's what you need to determine. And then what violations currently exist, you need to know that there are certain pods that do not comply to seccomp profile, which do not have anything as such, which is kind of locally running or something like that. You need to set runtime default. So those violations are there. You need to set some policies or determine certain violations, using different tools that you are going to implement eventually. And then you would get the idea of what things are there, what is my technical debt, how much I need to do, or what efforts do we need to take in order to secure our entire setup or entire cluster. And then who owns them, who is the owner of this cluster, who is the owner of the application, who is the database administrator, who is the authentication management administrator, all of this stuff. And then whether attacks are being detected or not, this is one of the most important question you need to answer while dealing with the maturity model of Kubernetes security. That if you don't know that you are being attacked, then how are you supposed to stop those kind of attacks? So there are different mechanisms you need to you can use to detect certain attacks. So for example, there is a Falco, which is majorly used for runtime detection. There is runtime detection of the attacks, or if there are any anomalous activities. Then there is App Armor tool, which is used for it. So different tools would help you in kind of determining if you are, let's say, if someone created a reverse shell in your container or in your pods, how do you detect that thing? No, there are hundreds and thousands of different pods you have. How do you determine if one pod in this particular namespace, in this particular cluster, or on this particular node is kind of creating a reverse shell, and then it is trying to brute force attack on your database systems? So these are the different types of attacks you need to determine by using different tools. And then whether we can prove all of this to an auditor. So that's the main question. So if you are dealing with any compliance agencies, or if your application is used worldwide, or there are particular customers who deal with sensitive technologies and all of these things, so there are different third party auditors that kind of assess the security measures that you have for your organization or your application workloads. And then if you can prove them, then only they will be giving you the license to distribute your applications through a region, a particular region. So that's why it's not just about tool integration, it's about answering these all questions and proving it to auditor that yes, my stuff is secure, and you can be sure of using it, and your data will not leak anywhere or something like that. So then a security model that would help uh, you know decide or define what things are there in, or what things do we need to consider while we start securing our Kubernetes things. So first of all, any cloud that you are using, you need to first determine, are you going to use the managed Kubernetes service, or you are going to do a self-managed, self-hosted Kubernetes service uh, cluster in that case. So mostly I have worked on AWS, or EKS is one of the managed Kubernetes service you can use. Or if you don't want to do it, you can use kubeadm or kops to create a cluster out of it, and which kind of creates master nodes, worker nodes, it creates security groups, it creates VPCs, subnets, or something like that, which is required for your cluster to run up healthy. So how is it secure or is it not secure? who are the admins, what permissions does the nodes have, what IAM principles are attached to it, and what rules are applied. So these all of these things comes under the security for the cloud only. Okay. Then comes, we build a cluster on this particular cloud environment, and then there are different components out of it. So there are worker nodes, there is master node, then there are certain control plane objects, then there are certain worker nodes objects. Are they secure? Is the HCD secure? Is it encrypted, or does it provide you uh, you know if that's not encrypted, does it provide you the uh, you know whatever information regarding the workload, if it's giving out the secrets that are stored in the secret config or config map, something like that. So is your API server secure? Is there any RBAC policies applied to it? These kind of questions you need to ask on a cluster level. So first is a cloud level security inspection. Then there is a cluster level security inspection. You need to determine what are the assets or are there for both of them, and then you need to uh, you know answer these questions alongside. Then comes the identity. Who can access the different objects that are associated with either the cluster, the application, or the cloud? Okay. So you need to manage the identity and access management. You need to apply RBAC. You need to apply SSO. You need to apply multi-factor authentication, or you need to apply some, what's that? A security keychain kind of thing. So that kind of access management you need to do, or identity management you need to do. Then comes network. After identity and access management comes the network. Are the networks policy set to only allow the users that should be using this application, or is it available to general public, or if anyone can see this from anywhere in the world? That you need to determine through network policies. Is there any firewall applied? Are there any security groups blocking access to certain ports, or all the ports of your instances are open? Is there any SSH allowed on port 22? Is it open to other people? So network configuration is also important. Are you using NAT gateways, or you are just giving out private subnet the access to entire internet? So these kind of things you need to first of all check on uh, the network level. Then comes the workload that are present, the node groups, the auto scaling policies for these nodes, uh, then whether you can you know try and defend a DOS attack. If there is any auto scaling policy set, is there any maximum number to like how max it can scale out, and how fast you can detect a DOS, I mean denial of service kind of attack, or network request flooding stuff. So workload security is also important. Then comes the application. Now, even if you have done all of these things on the cluster level, on the node level, on cloud level, and identity and access management, is the same thing applicable for your application? Or if someone can just log into your application, which is deployed on the cluster, and then he can brute force attack it and try to create a reverse shell, and then try to you know do SQL injection, and then the application is kind of you know updating the data or deleting the database, something like that. So if is your application secure, or are the APIs that are involved with your application, are those secure? Can someone try to send malicious packets to it, or malicious software scripts to it, and then it executes in its backend service or microservices, something like that? Or does your application or APIs leak sensitive data? So you again need to have a look into the application security for it. Then comes the data. Is your data secure, safe? Can you identify what are the PIIs, what is the sensitive data out of it? uh, you know this kind of stuff. And then, is it encrypted? Is the data access well set or not? This is what you need to answer for us. Then the supply chain related items, as we discussed earlier, there are a lot of third party tools, libraries that we consume while writing our code, while writing our CI/CD pipeline, while building our applications, or like while building Docker images. And then when those Docker images are stored in any artifact, are those things safe, uh, or someone can tamper with anything from out of anywhere? So supply chain security, right from code writing, code building, to Docker image building, to uploading them to a registry, and then to deploying them on the infrastructure. So the entire supply chain should be secured by using different mechanisms. Then runtime security, when your application is running, or when your cluster is up, you need to know what things go in it. Is someone trying to do something, is I mean, with or privilege escalation for their own workloads? Is someone trying to escaping the container and trying to get hold of the information that is there on the node? Is someone trying to see the volume mounts that you have made for your workload, and then if they can see some secret data in there? So these kind of things goes in when you deal with about the runtime security. So there are different tools that could help you in kind of doing that. Then comes monitoring of these workloads and the applications. You can use Prometheus, Grafana, ELK stack, alert manager kind of stuff to do the monitoring and observability thing. You can use Splunk for CM, which is security incident and event management, and all of this bunch of different stuff that could sum up into monitoring section, monitoring or observability stack. Then comes governance. So after doing all of these things, are you able to govern your entire Kubernetes workloads? If it's not just one workload, it's a lot of different things that you need to simultaneously manage. So governance is one thing. Are there any audit failures that could happen when you deal with your regulatory bodies? If there is any cybersecurity framework that is been assessed, or like let's say if there is a FedRAMP or GovRAMP assessment for your applications, and you want to serve the federal agencies or government agencies in US, so can you pass those check? So governance, regulations, and all these different things, compliance related stuff can be one of the most important stuff which decides the revenue or the customers of your applications. So that's why they are important. You need to certify your workloads in that case whenever someone uses it. So this is a basic Kubernetes model that you need to make sure, or you need to think about when you try to deal with K8 security. So it's not just the cluster security or HCD security or RBAC policies. Use cluster roles bindings and role bindings. It's not just that. It's a lot of different things. So let's talk about something that deals with components of the uh, Kubernetes associated components, and then we will discuss what things we can do to secure them, or what are the different components that we need to take care of when we talk about these components. So very first of all, as I mentioned, cloud infrastructure is the very first priority you need to secure. Then the control plane of the K8s cluster, then the host or the nodes, or the EC2 instances, let's say for an example, that your workloads run on. You need to secure those hosts themselves. So then identity and access management to entire infrastructure, even the host or the nodes or the things that are inside the cluster, to access those things, to access the API server, what things you have. We will see it in a bit. Then there is something which we know is namespace, or the logical boundary between one application and another application, and the multi-tenancy system that Kubernetes helps us. Then the workloads or the pods that run in the cluster on the worker nodes. Then the network, the secrets, the data. There are secrets that we use to have access to something else. I mean, some other thing, some sensitive data or some other application. So that's one stuff. The data is there, the etcd is there, which holds the cluster related information. Then there is the data that is there in the pvcs that you create, the sets that consumes pvcs. Then the applications and the apis that are associated with your application itself, your software that is going to be inside that cluster. Then the container images that this packaged under. Okay, then the software supply chain, then the CI/CD pipeline, then in infrastructure as code that is used to create the cloud infrastructure. Is it even secure or not? So that's again one thing. Then the admission control, which container can run where, on what nodes, what type of nodes, on what, I mean, how much memory of nodes is there, and those kind of stuff. So admission controls are required, so that in your cluster goes something that you know, and nothing that you know of should not be going on this cluster. So there is a kind of admission control policy. Then there is policy enforcement of how a workload should be running, what things a pod should be taken care of, and how it should be running on your infrastructure. Then the runtime security, logging and monitoring for your application workloads, the clusters, uh, and the data, and all of these different things. Then detection of attacks, or detection of any vulnerability or any risk in your containers. That is again one more stuff you need to take care about. And then vulnerability management of anything that is there associated with application, with third party libraries, with containers, with images, with the infrastructure, with the IaC code. If there is any misconfiguration or vulnerability uh, arising due to the IaC setup, so that's again that is what you need to take care about. Then the compliance and governance of that thing. Then how do you take a backup? So securing the backups is also important, because if you take a backup in some other region which is accessible by other people, and then if the backup is again restored by someone else, by if they steal that thing, so securing backup, encrypting that thing is also important. Then disaster recovery. So if something happens to your cluster, how fast you could recover out of it, how fast or how soon you can load balance the traffic to some another region or another cluster. If some pod dies, if certain pvc fails, and if your data is not able to read or reach up to database is unavailable, how fast you can recover from all of this is again the most important stuff you need to do. And then incidents response, if something comes up, if something goes down, if some attacks are occurring, if some vulnerabilities are found, how do you manage those incidents, and how do you respond to them? What is your you know chain of actions that you need to take, or how do you prioritize these different things? What is your response mechanism in that case? So that comes under incidents response mechanism. So then comes cloud infrastructure security. So first of all, Kubernetes usually for most of the times right now what we are looking at is it sits on AWS, Azure, or GCP, or any other infrastructure platform. So this is your outer security boundary. The very first line of security boundary is what? The cloud infrastructure security. Then what in the infrastructure? So IAM account subscriptions, who can see your account, your AWS accounts. Then VPC security groups, firewalls, private endpoints, and all of these different things. Then KMS, key management system services, load storage, storage. Then load balancer. Then web application firewalls or DDoS protection is what you need to do for your workloads. Then cloud audit logging. Then cloud security posture management stuff. you know all of these things will make sure that the very first boundary is secure. So before even reaching up to the cluster, the components surrounding the cluster should be managed well, and they should be secure first of all. And even if, like, let's say you have everything in your public subnets, then it will be easily accessible to entire world. Like your database is in publicly accessible. So then no matter what, how many security tools or how many security implementations you do, that will fail. So the very basic stuff is to secure the cloud infrastructure. That's first point. Then the control plane security. You need to protect the components that control the cluster, entire cluster. So what are those? API server, kubectl kind of thing, or curl responses to API servers. Only those people with the proper authority or rules or permissions should be able to communicate with the API server. You need to create RBAC policies and all of these different things. So at CD, then this is the brain of the cluster. Whatever goes inside the cluster is only through this. Then controller manager and then scheduler, where pods are getting scheduled. Are those nodes safe, or compatible, secure? Those nodes should do not have any what's that? What's the stuff that we say? Any defective or vulnerable packages, libraries, or software installed in that particular node. So that's thing. Then check whether the API server is publicly accessible or not. Uh, who can authenticate to the API server or the cluster, and whether the etcd is encrypted, whether the Kubernetes audit logging is enabled, whether anonymous access is disabled, and then whether control plane components are patched, they are updated, something like that. So for this managed Kubernetes, such as EKS, AKS, GKE, which is Google Kubernetes Engine, Azure Kubernetes Service, and Elastic Kubernetes Service from AWS. The provider handles the parts of this, but not all of your configuration responsibility. So you need to see, like when we talk about managed Kubernetes, most of the times the control plane components are not, what we can see. The master nodes are generally managed by the clusters that are managed from these cloud vendors. We only need to worry about the workloads that are on in that particular cluster. Then next is the node security or the host security that we know should be done. So worker nodes are effectively servers running many applications or many pods. They need to be secured. To secure the following for these workloads, first of all, the operating system that is used for these nodes, mostly which is Linux. No one runs cluster on Microsoft or Windows or Mac things. Everything is mostly Linux. So you need to know about Linux. You need to know how we secure Linux, how the users are managed in Linux, how the minimization or hardening of clusters, sorry, Linux is done. What is kernel, what are the security modules for kernel, what different types of exploitations could be done on that thing. So that's one. Then kubelet security. Kubelet is the component that sits in every worker node. You need to secure that kubelet from being accessible to other people other than API server. So then container runtime, because runtime attacks could eventually happen if you are working on containers with certain privileges or elevated permissions. So kind of that thing. The node IAM identity, the access to these nodes using IAM principles. Then metadata service, node network access. Okay, so uh, the nodes that are also configured with security groups. Then the NAT gateways, then other bunch of different things. So is this particular network properly secure or not? That you need to decide. So think about patching, minimal or immutable OS images. Minimal is the thing, like it only has, or it only is composed of what softwares you need. So let's take for an example Alpine images. They do not have much things installed in them. So if you use Alpine base images or Alpine operating system, then that would be fine for your application. And you can only have the control of installing the applications or libraries that you need. Nothing other than that is required. So instead of Ubuntu, instead of using that thing with entire stack, you don't need to do that. You can go with minimal base images. So then access SSH is enabled or not for this node, that need to be taken care of. Then disk encryption, the block storage that is associated with your node, with the EBS, is that encrypted or not? Now if that is, there are two EBS volumes attached with it, then root might get deleted. But if there is some data on the unattached, like after the node goes down, there could be an unattached uh, you know volume. So will that be, keeping the data secure? Is that encrypted or not? Is that accessible or not? That is what you need to think. Or if someone can use that volume and then attach it to different instance, same in the cloud environment. Then the node pool, you need to take care about how those are placed. There are instance placement things or EC2 placement mechanisms. How do you manage those node pool? What is the compute capacity? What is the security measures that you implement for this entire node pool? Then the runtime configuration and host level monitoring, you can make it happen using the certain tools. Let's say Qualys is there, which kind of does the runtime security of these different things. Okay. Then there is Wiz. Then there is what that Sysdig. A lot of different things. Sysdig is mostly majorly working for container level security. But like Qualys and then Aqua, and then Wiz, then a lot of different tools. Who's something like that. So they can help you secure this node. Okay. Then comes the identity and authentication and RBAC for your entire things. So first of all, there are two different types of identities that you need to take care of. One is human identity that access your clusters and applications. Let's say developers, site reliability engineers, platform engineers, and security engineers, and QA, a lot of different people that access your applications. And then there comes machine identities, which is pod, service accounts, and controllers, and then CI/CD that kind of access the environments. So we need to protect and restrict both while granting access to the environment. And we can use the following for IAM related stuff. So there could be SSO setup, there could be MFA, there could be Kubernetes RBACs, role-based access controls, and then there could be service accounts associated with them, short-lived credentials for accessing, letting access for a database to developer for certain period of time. Let's say 8 hours, 12 hours, 24 hours, something like that. So then role bindings, cluster role bindings, workload identities, and privileged access to something for a short time. So these are the different kind of things. Let's say you might have heard about power user who have certain kind of administrative access for a row for a cluster for some time. If they want to do, if there is a developer or DevOps engineer want to do something with the cluster. So these kind of things you need to worry about when you deal with identity and access management. So these are the controls you can add for your things. Okay, this is just one stuff. This is not the entire thing. Then namespace and multi-tenancy security. So namespace are basically logically isolated workloads or applications. So there is cluster. The hierarchy of that thing is nodes, worker nodes, then the cluster, then the worker nodes, and then the containers that run inside that thing are under certain namespace. So there is one default namespace which has certain items, and then there could be another logical isolations you can create using this namespace so that your applications are in different security boundaries. So these are automatically strong security. I mean, these are not automatically a secure boundary. Someone can access something which is in another namespace. So if one namespace is compromised, they can look into something which is in another namespace. So that's why you need to properly isolate them using RBAC network policies, then resource quota, pod security, and then admission policies, as we discussed earlier. So then comes pod and security container. So this is like one of the largest area to consider for security because everything mostly runs on pods and the containers that are inside them. So check if the containers can escape or compromise the node or other workloads. So check about root containers if some root containers are running with root privileges. Then privileged containers if they have access to volumes that is attached with the disk or the block storage that is there. Then Linux capabilities which are there, there are different set UIDs, get UIDs capabilities we have in Linux that could, help in privilege escalation. Someone can add themselves in the sudoers lead, sudoers list. So if that is allowed or not. So if privileged containers have the access to the Docker socket, that is also we need to take care of. Okay, or the container if they are using CRI, then what are the sockets that they can access? Then the secure computational profile, is that set or not? Okay, then you can use app armor or SC Linux. What are the things that are used mostly? So SC Linux is a Red Hat based Linux. Then host path or host PID, IPC kind of things. Are they accessible or not? Are they exposed or not? Host network, you need to have these list by hand so that you can have a checklist of checking what things are there and what things we need to secure. So are there only read only files, or someone can create something when they get the access of the container? If it is read only, then that is fine, but if it is not read only and they can have, or they can download any application from over the internet, then that could be a virus, that could be a malware kind of things that could infect the entire cluster. So you need to have read only file system, mostly the bin folder or the etc folder, which contains the most of the important files that are there for the operating system. The temporary file could be also a place where someone can find log files that are associated with the application. So that things are also required to be secured. Then resource or request limits, how much resources are being utilized from the pod of the node. Okay, so if some pod or some PVC claims 100% disk space of your block storage that is there, so that would be you know only one PVC would be consuming entire space. There would be no disk space left for other pods. So you need to limit the resource consumption for pods, stateful sets, or something like that. Then comes service account tokens uh, that are associated with your pods. So service account is what we use generally for authentication for the pods to different services. So let's say if I want my pod to have access to S3 bucket somewhere in the same account or in another account, so I need to create a policy. Then that policy is attached to a service account, and then that service account is consumed by this pod. Then only the pod will be able to access that particular principle that is mentioned in this IAM policy. So which is associated with that service account. So that's how you manage the access to your AWS or other cloud resources using service accounts for your pods. So that's again one thing. You can see an example of security context we can apply to our running containers or pods. So where we can mention like, okay, do not run as root user. So only run as non-root user. So that should be true. Then allow privilege escalation should be false. Read-only root file system should be true. Okay, if that is not applied, then it would be false, and then they can you know create files. They can install packages, something like that. Then you should drop all the Linux capabilities. Okay, PIDs, GIDs, IPCs, and all of those different things. Then security computational profile should be a runtime default. There another one is local, and then I don't remember the third one. So you can look up these different seccomp profile. There are three basically, and you can set it for your workloads. Then comes the part where we want to secure the network that is associated with the cluster and the AWS environment. So default deny for network policies and explicit permit or permissions should be necessary for ingress. I mean, which is ingress, it means incoming traffic. Egress, it means outgoing traffic. So outgoing should be checked, and only allowed for something that is only required. Not every pod requires an egress traffic, and not every egress or ingress is should be given to something that is in private subnets. So then comes the security for the following stuff. So how what paths you should secure. So internet to cluster access should be secured, the network and the routes that is there. Then you need to again check pod to pod communication is enabled or not. How secure is that? If one pod can communicate with a pod which is in another node, so should that be accessible? Is that a sensitive node which holds the database or certain persistent volume claims? Then namespace to namespace communication, then pod to database communication. Then we mentioned pod to cloud services, like one pod to an S3 bucket or some another service. You know, so that should be again secured. Pod to internet, and then DNS. Some DNS is resolving into some pod IP, something like that. And then control plane traffic should be also monitored or secured. Control plane, which would be mostly kubectl to API server, API server to controller manager, then controller manager to the kubelet, and then again controller manager to the etcd to the scheduler, something like that. Okay, so the control plane traffic should be also monitored and secured in that way. Then if there is one master node alongside with the another master node, two master nodes are managing your entire cluster. So that again comes handy for us. So you need to know, about Kubernetes architecture. As I'm talking with this, you might, not grab everything in the first go. You need to watch this entire video a couple of times because there are a lot of things that we are discussing in it. So secrets management and its security. As I mentioned, a lot of people use secrets nowadays for applications and the workloads, the share service accounts, as we mentioned. Those are one thing, but apart from service accounts, there are a lot of different things that we use outside the cluster. So there are different secrets that are used. So right from the entire secret life cycle, we need to make sure that it is secure. So right from the creation, how do we create? Where is it creating secret, and then how it is stored, and then how is it distributed to users? How users are consuming it? Are they giving these secrets to an AI agent, and then that AI is accessing your cluster? Okay, how that is being consumed, and then are these secrets getting rotated, or these sessions that are set, are those revoked in certain time period? So how these secrets are getting revoked? So you need to take care of the entire life cycle of secret generation or secret creation up to revocation and deletion, to secure them. Then don't leave your secrets inside a Git repository or container images or Helm values or Terraform state files unintentionally or intentionally. So that is what we need to make sure, that someone should not do this. And then use systems such as Vault or AWS Secret Manager, Azure Key Vault, or Google Secret Manager, ideally with workload identity rather than static credentials. So you should not use tokens, API tokens, or anything like that, which can expose your entire sensitive workloads or databases. Then comes the database security. So when we talk about data, we need to protect these following things that are included. So databases, object storage, persistent volumes, backups, snapshots, and application data. These are the all things that we need to consider when we ask about security of data. So consider the following controls to be implemented for securing data. Encryption at rest. Even though someone got the access of your database snapshots or backups, they should not be able to recreate that thing out of just this backup. That there should be some kind of encryption, and then there should be a key that is only required, that only key that would unlock this encrypted data. So if like half of the thing is done when you encrypt your database. So and then if you have strong key management service or system or their security, then it would be very hard to even grab or decrypt this particular data. So that's why encryption at rest is important. And then when someone is requesting data, if any authenticated or authorized user is now requesting this data who has the KMS keys, then only, I mean, if there is a man in the middle attack, so that should not expose the data that is flowing over the network. Okay, no packet should be exposing what is going out and into the database. So that's why data encryption in transit. In transit, it means whenever it is moving out or in to some place. So data encryption in transit is also one of the most important thing. Then, as I mentioned, KMS is one stuff you can use. Database authorization, data classification, and then once that data is classified into PIIs or general information, then you can mm, kind of give more restrictions towards that database. Then the retention of this data, how long do you want to retain it based on different policies or requirements? Is that data there for a long time or not? Then the backup security, whenever you take backup of these particular things, whether you dump it in S3 or somewhere else, you need to secure those. Otherwise, someone who has the access to S3 can see the backup data and then they can recreate that thing over there. So database audit logging is also one more important thing that you need to do. If is what happens on your databases. Does someone queries delete query? Okay. Does someone reads the sensitivity data out of the different tables that are there? So you can always have the data access log audit logs and all these things. Next would be application and API security. So now, once you have done security for all of these things, comes the secure a secure configuration cannot protect you from an application with the following types of vulnerabilities, as we earlier discussed. So SQL injections, broken authentication, remote code execution, insecure deserialization of data, and then authentication flaws, and then API vulnerabilities. These are some kind of things that are required or that should be taken care of from our end as an application developer. So Kubernetes security must connect to AppSec program. That is most important thing, because even if you have overall security for your cluster, but the application is not secure per se, then it can leak data, it can compromise your workloads, it can harm your entire security controls in a lot of different ways just because of the application. So you might have seen that meme where the entire person is wearing a metal gear, and then there comes an arrow, a SQL injection arrow, and then it pierces through the small gap that is there inside his eyes. So this is the thing that we usually see when we talk about application and API security. So we secure entire cluster, entire architecture, entire framework or infrastructure, and then we forgot to you know basically sanitize the input or filter the input that users are giving. So then SQL injection happened. So we should not be doing that. So that's why app security program consists of FAST, which is dealing with the code security, then SCA, which is for library security, and then DAST is for dynamically testing your applications when it is running. Uh, and then API security, threat modeling, and CI/CD security. So Kubernetes security should be connected to this program. And like one security tool is not, you might know that defense in depth is that there are multiple layers of security that we need to implement so that even if one is breached, another could make sure that the posture is not compromised, or the infrastructure or the data is not leaked. So that's why Kubernetes security is different, cloud security is different, and application security is different. Again, all of these are different than data security and network security. So a lot of different things you need to take care of about. And then comes the AI. So AI security and governance is again one more topic that we have discussed in this particular video. You can always watch it over here. Then comes container image security. So as we discussed, applications are there and they are containerized. We need to again secure the containerized workloads. So before an image enters the cluster, determine like where did it came from, who built that thing, what is the authenticity of that builds, what packages are inside it, does it contain, does the package contains any vulnerability or some malware or something like that. Okay, does it contain any secret, has it been modified, or is it approved, kind of thing. So we need to make sure what you build is the same thing that is shipped in the cluster. So is that modified between the build procedure to the artifact storage and to the cluster. So there is a registry where we store these images, and if that gets compromised, the artifactory or the registry, and then someone tries to modify some image and then he pushes his image into that registry, and then that is coming into your cluster. So that is a part of supply chain security flaw. So to not make this mistake, what we need to do is we can implement certain controls for securing the container images. So very first is the image vulnerability scanning that we can try. Then using minimal base images, as we mentioned earlier, Alpine base images, or Alpine, Linux. Then approved registry should be there, and then there should be software bill of materials that we create out of images. And then image signing is there. Image signing is mean once you sign this image, you know that this is the image I created at this time and this place, and this is secure. So that is what I built. That is what image sign. And then we verify this signature when it is being pulled on this cluster. So once you see that this is the same image that I signed and nothing has been tampered, so sign is just a hash value, and even if you give a space, the hash value changes. So that's why it becomes more secure when you sign the images, and then if the hash are not matching, then you need to reject these particular images. So signature verification should be done. And then there is container hardening priorities. You can check for these things. There are different levels, attestation, the provenance of this particular thing, a lot of different mechanisms that we go through. Is there any secret? So these are done through chp tool or utility, and then it grades your container based on how secure it is, how hardened it is. And if that is somewhere a grade A or grade B, then that should be fine. But if it grade C, E, D, then that is what you need to harden furthermore. So you need to have this in mind when you talk about container images. Then comes the software supply chain security. So think beyond just the image. There is not just one thing that you need to secure. You need to secure entire supply chain for it. So there are a lot of opportunity for an attacker between any of the following path. So right from the beginning of development, we see up to the KEDs. So when you are developing these things, the code and the libraries, when that libraries and the code is there in the source repository, then the dependencies that you use that I'm considering as libraries, then the CI pipeline, then the build procedure or system, then the container images, and then the registry, and then the deployment workflow, and finally the cluster. So this is the entire path of where attacker can attack. So protect the following for minimizing the supply chain risks. So Git and dependency sources. So most of people use open source dependencies or third party libraries from open sources. So you need to check the authenticity and general public license for this particular thing. Who was the creator? What code is inside these libraries? Are these libraries safe or not? And then whatever the code you are putting in your Git repository, that should be protected. So CI runners, then build credentials, artifacts, and registries, and deployment mechanisms. All of this should be secured. That's why I said this is a part of supply chain security that you need to take care about. So then next comes is the CI/CD, GitOps and IaC security. So whenever you kind of deploy your things. So you deploy your system, and your deployment system may effectively have production administrative right access. So CI/CD, GitOps mechanism, let's say Argo CD, and all of these things are used in your deployment mechanisms. So you need to secure all of these things, and not allow anyone to have delete permissions or privileged permissions to your accounts. So GitHub and GitLab, then Jenkins, Azure DevOps pipeline, then Terraform scripts. Someone should not be able to kind of run a TF destroy, Terraform destroy command. Um, so that's what. Then Helm, if that is being used, the charts should be secured. Then there is Argo CD or Flux that we use for continuous delivery of this state thing. You check the live cluster, and then you check the what's that, the Git repositories, and then you kind of try to manage all these things. So if someone with the access to GitLab or GitHub makes or updates any things in the manifest file for Kubernetes, and then Argo CD reconciles them in the live state. So there could be some deletion of your resources or something like that, and then there are certain pipelines that are consuming secrets, and then there are different runners that you use to build and deploy these applications. So you again need to secure this entire pipelines. The next is admission control and policy. So this is your security gate before Kubernetes accepts something. So look at the pod security admission, or there could be a Kyberno or open policy agent as gatekeeper that could be there. Okay. So this is important because it turns a security documentation into enforceable control. So you can just write certain documentation, and then it would apply it to make your admission control policies more securely accepting certain things. Okay. So then developer deploys a pod, and then admission controls check that if the pod is privileged, if that is privileged, then deny the pod from running. If it is running with root users or root permissions, then deny that thing. If that is an unsigned image, as we mentioned earlier with six-store or something like that, or cosign, then if that is an unsigned image, deny that thing. If that is somewhere from unknown registry, then again deny. These are the different uh, admission control policies. Again, then if a pod is not having memory limits set to it, then again deny that stuff. And then if that is compliant after all of these checks, and then only allow that particular image or container to run on that particular pod, inside that pod. So other than that, we are not able to go through these things and run pod. And if someone tries to uh, have an unprivileged root, unprivileged image, unprivileged or root non-root user, someone also has the signed image, but that signed image is from an registry which is unknown, then it could not be run specifically on that workload. So that's why we have to also add all of these things other than image security and signing these images. So admission control is one of the most important thing, a kind of gatekeeper for your workloads to run certain things. So now runtime security. Now everything can pass CI scanning and still be exploited tomorrow. Okay, that's why you need runtime security. You can do everything right, but if you miss the runtime security modules, then you can like say effectively that your security program was ineffective. Wordplay, boss. So you need to observe what containers actually do when they run in the cluster. That's why runtime security monitoring is one of the most important stuff. So unexpected shell, unexpected process, privilege escalation, then sensitive file access, crypto mining, suspicious network connections to some network that is not known to you, container escape attempts. So container basically escaping from the container onto the or onto the node, so that once you get the access of node, you can again use the container runtime interface CRI or container runtime to kind of get the access of other uh, containers that are running. So container escape attempts, and then as unexpected binary execution, something which is in your bin, which is not kind of allowed. So that's what you do for runtime security. One of the tool that we can discuss it in later videos would be a Falco or App Armor to kind of detect such kind of stuff. So then comes logging and monitoring and detection of all of these things. So collect security relevant telemetry information from where? From cloud, K8s APIs, audit logs, nodes and containers, applications, ingress, web application firewalls or DNS, then networks, then IAM, secrets or KMS, and then CI/CD and registry, and then databases. So these are the places that you need to uh, check for security relevant telemetry information. And once you have them, you could dump it all into a CM or security analytics platform and build actionable detections. So Splunk, Sentinel, Elasticsearch, or Google SecOps, these are the different platforms for runtime monitoring and security incident and event management kind of stuff. And then you can derive certain findings out of it, and then you can work on those findings, and then you can automate certain responses when you find certain events occurring. So that's the kind of thing that you can do using stuff. Then is vulnerability management program for your entire cluster and entire application. So scanning alone isn't vulnerability management. You need to do these things. You need to discover first what are these vulnerabilities inside your workloads, inside your images, inside your code, inside your libraries, inside your secrets, and all of these things. Then you need to prioritize what things are critical, what are medium, what are low, or what are just informational stuff. Then you need to assign the vulnerabilities to the people that should be owner of this thing, and that should be applying the changes. And then once they remediate that thing, then you need to verify, rescan, and then report that thing to the people that it has been fixed or it is not fixed. And you need to again work on that stuff. You need to rescan this thing. So vulnerability management is not just finding vulnerabilities. It's about prioritizing them, fixing them, and then again assessing your entire uh, you know mechanisms or your assets for vulnerabilities. So prioritization should consist CVSS, exploitability, internet exposure, runtime usage, workload criticality, and data sensitivity and compensating controls. So these are the things you can take care of when you want to prioritize. So if CVS is the vulnerability score that you have is 10, so that is the very first priority you should be given, which is a critical vulnerability. And then if there are two vulnerabilities out of it, so one out of which is exploitable and another one is not, so the vulnerability which is not exploitable should not be a priority. It should prevail. It should not prevail uh, to the one which is exploitable. So there is EPSS that is going to give you a exploit prediction scoring system for this. Um, so that gives you exploitability of that thing. Then again, if the exploitable vulnerability is not exposed to internet, then you should not be worried about. So these are the things you need to consider when you prioritize vulnerability, and or there are bunch of different thousands of vulnerabilities. Which ones you will fix first? So that's a general interview question you need to or you get in interviews when you talk about gate security. So then comes compliance and security posture for your applications. So continuously measure your clusters against your security baselines that you kind of use or you have available online. So which is CIS Kubernetes benchmark or Kubernetes pod security standards or NSA and CISA Kubernetes hardening guidance, NIST or organizational security policies that you have in your own organization. So these are the references you can have, and then you can create certain security baselines, and then you need to continuously monitor your clusters if they match the security baselines or not. If they do not match, then you can always reach out to the DevOps team or the development team to make sure that it is as per the companies or the regulatory guidelines. So tools such as Kubescape, Kubebench, Trivy, Keyworno policy reports can provide evidences and reports out of it, so that you can make sure that you are compliant and secure. So backup and disaster recovery is like security includes recovery as well. Like people say, like recovery of this thing or disaster management and high availability is a part that only SRE means site reliability engineers should focus on majorly, or platform engineers are aware about or responsible about. So it's not the thing. Security also includes this recovery stuff. So what happens if an attacker deletes a namespace? Can you reconcile those deleted namespace and the pods and the PVCs that were included as a part of that namespace? If that is okay, then you are good. If you cannot reconcile those changes after it is deleted, then what would happen? Your application goes down, your data is lost, something like that would happen generally. So that's why once you delete this namespace, you need to recreate that PVC, you recreate that block storage and the data that is there. So it is really important for the backup and the disaster recovery stuff. So then is the data encrypted, or if that's not encrypted, and then if some attackers attack, can they steal your data? And then what if uh, you know or like if an attacker encrypts your data, if that was not already encrypted, can you again read that data? Is there any backup for that data? So now if some attacker destroys the cluster, how soon can you bring up the entire cluster from scratch? If attacker compromises any credentials, can you rotate it fast? If that is detected, can you rotate it, and can you replace that thing for the service accounts or whatever the profiles that are using that credentials? Or what if he deletes any databases? Do you have a backup policy or a retention policy that you can use and you can bring back your data up? And what if he corrupts your backups? Is there any multi-region backup setup that you have done? So you need to protect backup separately and regularly test restoration mechanisms out of it, so that you can make sure that nothing could make your application go down. So next is incident response. For certain things, you need to have a CADE specific response procedure, so that like there should be an alert, and then you need to identify what the pod are affected on what nodes. You need to preserve evidences or logs of that thing, then isolate the workload, and then revoke credentials of that thing with any service account, or you need to detach it from it, and then determine the attack path, and then patch or rebuild that particular pod, or redeploy a clean image, and then hunt across cluster if such alerts are generated or such attacks are happen. uh, then you also need to do post incident review, determine the root cause analysis and all of these things of happening some incident, and then you need to learn from that particular analysis. And then you need to again implement certain controls that you should, I mean, this kind of thing should not happen. You need to update the WAF configurations, you need to apply the admission control policy, something like that should be done, so that such kind of attack should never happen again in your workload. So that's what goes around post incident review. Once you have done all of these things, once you have sorted all of this stuff. So particularly important Kubernetes principle is to rebuild or redeploy compromised workloads from trusted artifacts, rather than logging into a compromised container and trying to clean it manually. So if someone installs a malware, you should be fast enough to destroy that container, and then respin or respun that particular stuff, uh, or redeploy or rebuild that thing, the compromised workload, so that it should go down, and you should not just go log in into instances and kind of try to delete the malware and regain the control of that workload. So next is controls that we need to implement to secure our entire cluster architecture. So SSO, MFA, least privileges, Cloud IAM principles, or roles that are there, the users are there in the identity and access management. Then private or restricted Kubernetes APIs, API servers, Then remove unnecessary cluster admin and wildcard RBAC policies that are implemented. Disable certain unnecessary service account tokens and the mountings that are done for certain pods. Then pod security restrictions and workload security context should be there. Block privilege and root host path host network workloads by default, and then default deny ingress and egress network policies as we discussed earlier. Then external secret manager plus workload identity should be used. Then KMS encryption and TLS should be applied. Then container image scanning in CI/CD, then SBOM and image signing, admission control policies, Kubernetes and cloud audit logs, runtime detection and regular CIS, NSA, and for Kubernetes posture management and its assessment should be done. So these are the different controls you can implement for your cluster and cloud infrastructure so that a lot of things are secure. Again, we think we missed the DLP mechanisms or DAM mechanisms that could be implemented, which is data loss protection or prevention, you can say, and then database access management mechanisms, okay, or principles, something like that, or tools that you can, or DAM tools or DLP tools, DSPM, data security posture management tools. So these are related to clusters, clouds, and then the data for your workloads. So then there are different security tools that you can use. We can say what security area is there and what tools you can implement. If you want to know your Kubernetes security posture, you need to go with these tools: Kubescape, Trivy, or Kubebench, which can scan your cluster and then tell you how secure your Kubernetes clusters are, or if they are not secure at all. So that's why security posture is really important. You can find something like my cluster is 50% secure, my cluster is 100% secure from these type of tools. Then there are CIS benchmarks that you can use Kubebench and Kubescape to find out. So CIS is a hardening mechanism for clusters and all the nodes that are associated with them. So once you use Kubebench, you will easily have that information at hand. So image scanning should be done using Trivy or Gripe, Trivy, Aquasec Trivy or Trivy. Then IC scanning should be done through Trivy, Chekovi, TFSec or Kix framework. That's what would make sure that whatever cluster you are bringing up, whatever the nodes and the networking VPC infrastructure you are building up using the infrastructure as code mechanisms, they are safe and secure and not misconfigured. So that's why IIC scanning is really important. Then dependency or SCA, software composition analysis should be done through Trivy, Sneak, or Dependabot, GitHub Dependabot if you are using GitHubs in that case, and GitLeaks for GitLab, something like that. Oh, sorry, that's again for secret scanning. That's another tool. So GitLeaks kind of scans for if there are any exposed secrets in your repository or your container. You can go with GitLeaks and Trufflehawk for that. And then you need to create software bill of material as SBOM using Sift or Trivy, and then image signing for using Cosign or Sixstore. Administration control could be done using Kyverno or Open Policy Agent or Gatekeeper. Then there is another runtime security tool which we discussed: Falco, Tetragon, AppArmor. Network security could be using Cilium or Calico. Then network observability can be done using Hubble. You need to observe what things goes into network, goes in and goes out. So that's kind of possible using Hubble. Then secrets should be used from Vault or Cloud Secret Managers. Then CM, which is security incident and security incident and event management. As we mentioned, that we need to collect or aggregate all of these logs and then feed it to a particular tool. So Splunk, Sentinel, Google SecOps are those kind of tools which would collect all these things and derive meaningful data for you in that case. So that is a part of security telemetry kind of stuff. So cloud security posture management can be done using Prisma, Cloud, Viz, Qualys, other things. And then enterprise cloud native application security tools like Sysdig Viz, Aqua, Qualys, Tenable. These are the stuff that you can use. Again, there is one defect dojo, which kind of aggregates all of these findings and give you out in a particular format in one particular dashboard. Then application security, as we mentioned, SAST, SCA, DAST could be a part of this thing, and tools like SonarQube, Sneak, CodeQL, SemGrep can be used in order to do that. Then for DAST, you can go with OAuth, ZAP, and Burp Suite. And then API security could be done using Mayhem API and Burp or Salt tools. So these are the different tools you need to uh, worry about, and you can always have them in place for your security. So that's all about Kubernetes security, and it's a long video. So we have discussed it in very great detail. And if someone, I mean, this is a single video that you can watch, and you can get the entire gist of what we need to do for Kubernetes security, not just securing etcd, encrypting that thing and applying rule RBAC and API server security, kind of that thing. We have discussed end to end security for Kubernetes, right from the code to cloud to CI/CD to runtime detection to images to image signing, image registry, and all of these different things. Admission control, RBACs, a lot of different stuff. So this is only single short video that you need to watch. And that's all you can learn about Kubernetes security. Again, thank you guys for watching this video. This was entire long video session. This could be a short movie, one and a half hour movie for you, your Kubernetes security journey. So that's all for this video, and let me know if we missed something, if we can add some points. And see you guys in some another video with such another information. So until then, keep learning and bye.